this video, we're going to be looking at the cosine law. So in last video, we looked at the sine law and how the sine function or sinusoidal function relates to triangles. But now what we're looking at is how the cosine function relates to triangles. So same kind of idea behind the sine law applies to the cosine law, where we're just going to have a new rule that helps us find either side lengths or angles given a certain problem that we're working on. So let's take a close look at what the cosine law says. It says that for angles A, B, and C, or at the vertices of the triangle, the angles, we have side lengths that are across from those or opposite of those, and those are labeled as A, B, and C. So we can find missing sides or angles by using the formula c squared equals a squared plus b squared minus 2ab cos c. And so one thing I want to note right away before we go into the problems is that when we're looking at the cosine law, one really important thing to look at is that if we're solving for the angle, our angle will always be the letter that's on the end here. So it doesn't necessarily have to be that C is this spot here. It could be B, it could be A, it could be whatever letter is associated with whatever angle we're looking for. It's just that in the general form, this is how the letters should be arranged. And the special part about this formula here is that whatever angle we have or that we can use to solve for anything within this given equation, it's always going to be that the isolated one on the left-hand side here is the same letter as the angle that's on the right-hand side. So that's how you should always associate it. And then the two individual letters on the right-hand side, so A and B squared, or let's say C squared and B squared, or A squared and C squared, those letters appear a single time next to the two here. So it's just remembering this order of if we have that angle that's a certain letter, then it's going to match the letter that's on the left-hand side of the equals sign. But this is going to help us solve for whatever we're looking for within a triangle, whether it be a side or an angle. Starting with example 1, we have solve for the side length C, then solve for angle A. So right away, what we have is we have the information that we are going to be looking for a missing side, and we know that our missing side or the side length C is always going to be the opposite of where the C angle is. So technically we are looking for that length there. And that should make sense, right? Because if we have a missing side, then of course that's going to be one of the ones we're going to be looking for, because we already know our 11 and 5 are our other two sides here. So for step 1, what we should do is we should write out what the equation is based on what we're looking for. Simple enough, we can actually go right back up to our formula here, and that's actually going to be the exact same formula in the same order we're going to use for our cosine law to solve this, because we're looking for side C. So c squared is equal to a squared plus b squared minus 2ab cosine c. So let's fill in what we know. We don't know c, obviously, because that's what we're solving for. We know A, which is the opposite of the A angle, so that's going to be 11 squared, plus we know B, which is the opposite of the B vertex, which is 5 squared, minus 2, 11 for A, 5 for B, and then cosine. And then at the angle at C here, we have 20 degrees, so we can just write that in. And these two are multiplied there. Now what we have to do to isolate for C is we just have to square root everything on both sides to give an individual C. So thus, C is equal to square root 11 squared plus 5 squared minus 2, 11, 5, and then cos 20. So this is equal to square root 42.633, which is then equal to 6 point, and let's round it to the nearest tenth, 6.5. So thus C is equal to 6.5, and then we can actually just write that for our C value instead of the star. So I'm going to erase that star there, and then we can just write in our 6.5. Perfect, but we're not quite done yet because they asked for a second detail. The second detail they asked for was, let's solve for the angle A once we know that side C. So for step 2, we need to write it such that we can get the formula that gives us that angle. So remember, if we go back up to our cosine law here, technically these letters can be written in any order, but depending on the order we write them in to solve for, it's going to have an impact on where we write the letters. So if we know that we need an angle A instead, that means that we're going to have an A on the left-hand side starting here, and then the other letters are just going to swap. So let's do that below here. So we go back down, swap up here. So now we get, our formula should look like a squared is equal to, let's put b squared first, plus c squared minus 2. Remember, it's individuals of the letters that are on that right-hand side with us, so b and c. And then we have cosine of a. And do we see how that the a squared and then the cos a, whatever the angle letter is, we have on the left-hand side of the equal side individually? Perfect. Now what we have to do is we can either substitute values in right away, so we could put in all the values we know and then try and isolate for the a angle, or we can isolate just in the variable sense right now and then plug in numbers. So I think that's what I'm going to do to keep it simple, is just I'm going to isolate for the a value or the specific a angle. So if I move the cos over to the other side, or this part here, I'm going to add it to both sides. So I'm going to get 2bc cos a, and that's going to be added to both sides. And so when I add it to both sides, it's going to cancel on that right, and then we're going to get a new form of a squared plus 2bc cos a is equal to b squared plus c squared. Okay. And then now I have to move that a over, so I'm going to move the a squared, subtract it from both sides. So now I get 2bc cos a is equal to b squared plus c squared minus a squared. And now I'm going to divide that 2bc to get it off the cos. So now we get cos a is equal to b squared plus c squared minus a squared all over 2bc. And then now remember, if we want to get rid of the cos off that angle A, what we have to do is we have to do the inverse or arc cos. So over off and to the right here, I'm going to write A is equal to cos inverse or arc cos times b, or with in the brackets, b squared plus c squared minus a squared all over 2bc. Perfect. Now we have our angle A isolated. So what we can do is actually just sub in each of the values we didn't know, or we know, but we wanted to we isolated that angle A. So now we have cos inverse of b squared. If we go to our triangle, it's 5 goes in for that. So we have 5 squared plus 11 squared, which was c, or whoops, my bad there. We have 5 squared, which was b. We have c, which was 6.5 squared. And then minus a, which was 11 squared. All over 2bc. B was 5. And c was the 6.5. And we can close that bracket. When we put this into our calculator, we're going to get cos inverse of negative 0.826. And then when we calculate that, we can say A is equal to, it's going to be 145.8 degrees. And that was to the nearest tenth. So that is our solution for A, which we can go up and write that in as the 145.8 degrees. And that should make sense. Based on the angle, it's a lot greater than 90, obviously. It's an open angle like that. very large angle. So we would estimate it's going to be somewhere in that like 150, 130 range. That would be pretty typical for an angle that looks like that. So we can always go back to our triangle, and basically if we got an angle that was really small, we would know something's wrong, especially for angle A like that. So we should, and the other indication of that we should have a bigger angle is that if our side length across from or opposite of our angle A is really big in comparison to the other ones, then we know the angle should be very big in comparison to the other angles of the triangle. Okay, so we're going to work on example 2. Example 2 says determine the length of the third side. So the third side is the one that's indicated by the star because it's the only side we don't know currently, and it represents side L. So we can actually write out our sides here that we know because they're always opposite of our angles. So we have side L, we have side M, and we have side N. So according to that, let's write out our cosine law that can help us solve for this length L we don't know. So L squared is equal to M squared plus N squared minus 2M and N cosine L. And now we can plug in everything we do know because we know everything besides the length L. So L squared is equal to, the side length M is 13 plus N, which is 29, minus 2, 13, 29, and then cosine L was 41 degrees. Okay, now it's just about simplifying this. So in order to simplify this and get a single L or just the L side, we have to square root both sides. So when we square root the left and then we square root our other side here, we're just going to rewrite everything but with a square root above it. There we go. And then a single L is equal to square root of 440.948, which is equal to 20.99, which we'll just round to 21.0 as the length L. So we can actually write 21 in place of that star of the missing side, and that's going to be our solution for that one. Let's work on example 3 here. So example 3 says determine the measure of the indicated angle. The indicated angle for this problem is going to be C, with the little blue half arch representing the indicated angle. What we know from cosine law is that whatever angle we're looking for, that automatically means that that variable of side length is going to be the one that's isolated on the left-hand side of our cosine law. So what I mean by that is when we're writing it, we know that C is going to be the one that's on the left-hand side, and then we can start writing out the variables according to cosine law for the rest of them. So we have a squared plus b squared minus 2ab cosine of C, because we're looking for the C angle. Now let's do what we did before in example 1, where we just isolated for that angle variable right away. Instead of plugging in the numbers and then trying to reallocate those numbers, let's just do let's isolate for C right away. So in order to isolate for that, I'm going to add 2ab cosine C, and I'm going to add it to both sides. That's going to cancel it off the left-hand side here, or sorry, off the right-hand side. So now our new form is going to be C squared plus 2ab cos C is equal to a squared plus b squared. Now I want to subtract that C squared from both sides so that I can get one step closer to isolating for that C angle. It's going to cancel off on our left-hand side here. So now we have 2ab cosine C is equal to a squared plus b squared minus c squared. Now I have to divide the 2ab from that cosine C. That will cancel the 2ab on the left and leave us with cosine C is equal to a squared plus b squared minus c squared all over 2ab. And finally, when we're looking at this, what we have to do is say, well, in order to get the angle C alone, or specifically the C that is with the cos, we have to inverse the cos or arc cos. So we get C is equal to cosine inverse or arc cos with a squared plus b squared minus c squared over 2ab in the brackets. And now let's plug in the values we do know from our triangle into a, b, and c. So c squared is equal to cos inverse of a squared. Well, a was going to be opposite of the a angle, so that's 20 squared, plus b opposite was 13 squared, minus c, which was 31 squared, all over 2. A was going to be 20 and b was 13. Right, and then when we simplify that inner bracket, what we get is negative 0.7538. Put that into our calculator, we get C is equal to 138.92. And I'm just going to round to the nearest tenth, so we can also say that C is equal to 138.9. So that is the angle C that we were looking for. And so we can actually go and fill that up into our triangle here. 138.9 degrees. And that should make sense, right? Because we have this angle that's obviously greater than 90 degrees. We have a side length that's fairly large and bigger in comparison than the other two. So its angle should be the largest of the three, which clearly by the diagram this confirms, and clearly by our work it confirms.